today's lecture. Hopefully you guys are all here for the exam revision lecture for HSC Maths Advanced. Just like to start off by saying welcome. We're just going to start today with a quick welcome to HR Notes, just in case you haven't seen us before. Essentially, HR Notes is just a company with resources and tutoring for HSC and prelim students. That's for New South Wales. We also do stuff for other states, but hopefully all of you guys are here for New South Wales HSC, so the other states don't particularly matter for you. If you want to check it out, you can just look at hrnotes.com. We've got heaps of free resources on HR Notes, so we're looking at some study notes, which are just like a comprehensive and complete notes for HSC courses that cover each of the syllabus points and include heaps of examples as part of each of your syllabus points. We've got lectures just like this one that are free to help you learn content and get familiar with different question types. Looking at discussions that are essentially just like Q&As with moderators and other students to share different experiences with exams, exam questions. You can ask questions of past students about their experiences, recommended study techniques, things like that. Then different videos that help you just engage with your content just a bit of a different way. Newsletters to stay up to date on the HSC. If you're at that point where you're trying to look at your ATAR calculator, there's an ATAR calculator available. Different articles that have heaps of study tips and strategies, and lots of other resources as well. So those other resources include TutorSmart, which is the HR Notes tutoring platform for Year 12 and Year 11 students. And it's run by past HSC students who have done really well in whatever subject you're looking at, so they can give you some expertise and some tips on how to do well in those subjects if you're interested. Got different study guides available that you can purchase with revision materials and practice questions based on your syllabus points. And there's also HR Notes Plus. That's just got notes for every single HSC subject, as well as text guides for all of your English texts as well. So we'll just start today with a little bit about me, because I'm just now remembering that I forgot to introduce myself. Hi, I'm Alice, and I'm going to be the lecturer for today. So I'm currently studying medicine at the University of Newcastle. If any of you guys are thinking about medicine, would highly recommend Newcastle. Of course, I'm a little bit biased, but I absolutely love the program. So I graduated in 2022 with an ATAR of 99.3. So these are the subjects I did. Did Bio, Echos, English Advanced, Maths Advanced, and 2-Unit Religion. And if any of you guys are interested, I tutor all of these at TutorSmart if you're looking for a little bit of extra help before the HSC. And I also run the HSC Maths Advanced class if any of you guys are interested in that. So this is my second HR Notes lecture series, and it's my first time doing the intensive sessions in preparation for your HSC exams. So I also lectured Advanced Maths in July, if any of you guys looked at that. And like I said, I tutor the HSC Maths Advanced class. It's me teaching the course. I try and create specific resources and things for you to look at to help you do and achieve your goals for maths. And like I said, I also do prep tutoring and HSC prep if anyone is interested. But yeah, so we're going to start today with a little bit of an overview. At the bottom of the page here, I'll just circle it for you. You'll see these different little, I guess, guides as to what section we're in. So each of these will become blue, just like this one is, when we are looking at that particular section. So you can help yourself keep on track of what we're looking at in each of the sections of today's lectures. But essentially, I'm just going to start with looking at today's lecture. So today, you're here because you're getting ready for your last ever maths exam. And that exam is around 1 month away. So this lecture is aimed at preparing you for all your exams by covering different types of questions for all the HSC Maths Advanced topics, with a few of my tips and tricks along the way for how to approach each of these question types. So this lecture has got a really big focus on types of questions rather than actually learning the content. So you're prepared for what you'll see in your exams. So if you're looking for a little bit more about actually revising particular content rather than just focusing on application style questions, have a look back through some of the past lectures and you'll be able to see a little bit more on content itself. But hopefully at this point you guys are all ready to start looking at application style questions. Just a little side note, you've finally done year 12, yay. It's an exciting time. I know from experience it's easy to get mixed up in all the chaos and the stress of getting ready for your final exams, but don't forget to enjoy the fun parts of year 12 too, and enjoy the fact that you're finally finished your actual formal schooling. That being said, take advantage of everything your school's offering, everything you can find online in terms of getting ready, and I have no doubt you will be able to answer any questions you're given. Make sure that even in this time you give yourself a little bit of structure. I know once you finish your 12 it can be really tempting to just go with the flow of every day because you're so used to having such an uptight, tightly regulated schedule, but promise me and promise yourselves that you will create some kind of schedule for your studying. Just give yourself a little bit of structure to make sure that you're studying for each of your subjects and you're giving equal time to each of those subjects as well. Alrighty, so we're going to be starting today's lecture by going over what is going to be in the lecture. Anyway, that was a bit of a convoluted way to say these are the topics we're going to be covering. So we are going to first start by looking at the exam structure for your HSC exam. Just to give you a few of my tips as to approaching the exam, get yourself super familiar with what that exam is going to look like. Even though you would have already done your trial and it'll be pretty similar, thought it would just be good to go over that again, make sure you're really well versed on what that exam structure is going to look like. Then we are going to go into looking at some trigonometry questions, some of the harder application style questions you might see. We'll look a little bit at calculus, then do some stuff on sequences and series, which includes, of course, your financial math stuff. Then have a little bit of a look at statistics, which from my experience is the topic everybody kind of forgets exists. And a lot of people forget to go over that, so we'll look at some questions there. And then we'll finish off with some stuff on functions before we have a few look through some exam tips and a bit of a summary of how to get ready between now and your HSC exam. So we're going to be using real questions that have appeared in recent HSC and trial examinations. If you have questions at any point and you're watching live, you can type them in the chat and somebody will answer those questions for you. Okay, so without further ado, we're going to have a bit of a look at framing questions when we're looking at HSC math style questions. So the first thing we want to do when we're thinking about how to frame a question is thinking about understanding the question itself. Now this seems really self-explanatory, but a lot of mistakes I see made in HSC maths come from misunderstanding the questions themselves. So when we're thinking about this, it can be really useful to write down what you're thinking on the left part of the page. Oftentimes this isn't even going to get scanned, so you don't even have to worry about like what it looks like, how messy your writing is or anything. And with maths, you do tend to have enough time to take a few seconds to actually think about what the question itself is asking you. So the first thing we want to think about is what information have you been given in terms of variables? So this can be things like when you're looking at trigonometry questions that are using applications of trigonometric graphs, thinking about things like if you're finding like height of a tide or, at what time does something happen, those are your variables and they may be given to you in the question, but you also want to be thinking about what variable are you trying to find. Particularly with your application style questions, thinking about variables is really important because it'll give you like a really good sense of what are you actually trying to solve for. The question will always give you some variable that you are trying to find, and then they will give you other variables that will help you find a particular answer. The stuff about variables doesn't tend to be as important when you're looking at more straightforward questions when they're just asking you to differentiate or integrate something, because your variable is just whatever polynomial you're integrating or differentiating for. But good to think about what information have you been given in terms of your variables, and what variable are you going to be trying to find. Then you want to think about what information have you been given, but it relies on you having to make an assumption. Now, this can be a little bit of a grey, murky area because you don't want to make too many assumptions. I will be super honest, never make an assumption about a graph or about like an image just because something looks like a right angle, unless you've got that little box drawn in the corner. And it looks, I'll show you what I mean, looks something like this. Unless that box is drawn in the corner, don't assume it's a right angle. So you do have to be careful with assumptions, but I'm thinking things like if it's telling you that you're going to be focusing on a pack of cards, you can assume that the pack of cards is going to have 52 cards in it, unless stated otherwise. Same thing about a dice. Unless stated otherwise, you're going to have your standard 6-sided dice. It's all those sort of common sense things that unless stated otherwise, so sometimes you will get questions that are like, you've got like a 12-sided dice or whatever, but unless it's stated, you can assume it's just your regular stock standard dice, deck of cards, think about you're going to have 24 hours in a day, things like that. Then the third thing you want to be thinking about is, what is your final answer going to look like? So this is thinking in terms of what units are you going to have. Your units are often a really big giveaway of what your final answer needs to look like, So for example, thinking back to an application of a trigonometric graph, if the answer tells you to give your solution in meters, then you're going to be finding some kind of distance, okay? And that's a really good indicator of what steps you're going to have to take to get there. Thinking, is your answer going to be in time? You're going to have like x's in your answer. If you're thinking about like differentiation or integration, thinking about if you're integrating something, your answer is going to have a plus c in it, unless you've been given data to, help you work out what that plus c is. So you want to be thinking about what that final answer is going to look like, and then that is usually a really big giveaway for step 3 on how you actually solve it. So then the second step with framing questions is going to be recalling things. So you want to be thinking about, what formulas do you need? Are they on your formula sheet? Is it something you just remember? Write down that formula. Be super, super, super careful you write down the formula correctly. I think a lot of mistakes come in maths from miswriting a formula, and it's things like doing a plus instead of a minus, or forgetting to add a squared on something. And that one little mistake can cost you at least 1 mark, maybe marks for the entire question, because you've written down one thing wrong. So make sure you've written down your formula right. Think about what particular methods and steps you might need to use to answer the particular question. And then you want to be thinking about, how can you get from the information you've been given, the assumptions you've had to make, to the final answer. So what sort of things are you going to be doing to get there? I'd recommend writing this on the right side of the page, or to the right of what you've written in for part 1 up here. Okay. Then the third thing you're going to want to be doing is solve the question. Step by step, go down the page, or you can draw a line in the middle and do half on the left side of the line, half on the right side of the line. You want to make sure that however you're solving the question, you do it really clearly and you've got like a methodical way to go like line under line. Otherwise your marker is going to get really confused and they might not be able to give you marks for your working out if you've done the question in a bit of a weird way that they can't really track what you're doing. Then finally, we've got a checklist for success as step 4 to framing questions in the HSC. So the first thing you want to do, and I guess what all of this is trying to do, is check your answers make sense. So firstly, check all the information you've been given makes sense. So that's like checking that your final answer sort of makes sense with the information you've already been given. So it's like, if you're looking at units of something, we're thinking about money in a financial maths question. If he's only putting in, $500 into an annuity account for 2 years, ending up with like $150,000 is a little bit unreasonable. So make things make sense. Make sure everything sort of fits with the information you've been given. You want to be checking all the information and all the variables you've put in make sense with the information you've been given in the question stem. Then next, for 2, you want to make sure and check once more that all your formulas are written correctly and the steps you've taken are correct. Just because one little mistake in writing down your formula can mean you miss out on all the marks for the question if you've made the mistake in line 1. Then you want to check each line of working for any mistakes. Again, looking at little things about, have you accidentally multiplied something wrong? Have you done a plus instead of a minus? Divided instead of multiplied? Just checking for each of those little mistakes that sometimes you might miss. Now, with maths, I would say personally, you do have enough time to do this as you go through the questions. If you are getting towards the end of the paper and you're feeling like you're a little bit low on time and you want to have a little bit more time to just go through questions, this checklist for success can be something that you come back to after you've had time to answer all the questions. So if you are running low on time, your checklist can wait until you finish all the questions and you come back for it. But in my experience, I will say you probably do have enough time to come back to the checklist, even if you feel like you need to answer the rest of the questions. So the next thing I'm going to talk about is summaries in maths. So hopefully you guys have written some summaries by this point because the exam's closely coming up. But what we're looking at here is why a summary is important. So I think writing summaries for each of the new concepts you learn, at this point, it's probably not worth going back and starting from the very beginning. So sort of write summaries for questions and new concepts you come across as you continue to learn the content and as you continue to revise. So for example, if you get a question wrong in a particular exam, write a little summary for that question and that question type. So you want to be including the relevant theory and the formula, and then you can include a worked example. So that could be including the question that you got wrong and just writing the correct solution and annotating that solution to see like why you did certain things, what the method looks like. Your summaries are really good things to go back on when you forget how to use a certain formula or how to work out a particular question type. And they are really good things to sort of just quickly read over the morning of your exam, because the morning of that exam, you don't want to stress yourself out. You don't want to be trying to do all these really hard questions, because if you accidentally forget something, you're going to get stressed out like, oh, I don't know anything, and oh, what if this question comes up in the exam? You don't want to do that. The morning of your exam, you just want to prepare your brain for what you might be seeing. So just flicking through some summaries, looking at questions that already have solutions so you don't have to stress about whether or not you remember a solution to something. Really good thing just to keep your brain ready and sort of activate your brain before you go into that exam. So we'll be going through heaps of questions in today's lecture. So follow through the lecture and start writing down some of the worked examples for some of the important concepts that we look at. Like I said just before, at this point in your revision, I wouldn't say it's worth going back to the beginning of the syllabus and trying to write summaries. I think at this point it would just be a lot of time wasted when you could just be doing, I guess, just more practice questions. So keep that in mind, but if it helps you learn, it helps you learn, and don't let me stop you. So just a little bit about what the syllabus sort of looks like. So the further you get down the hierarchy, so your hierarchy begins with your topic itself. So in this example, we've got calculus as the topic itself. Then you get a little differentiation topic. Here you've got your subtopics. And then within that, you've got question types. And then within your question types, you've got methods. So this is typically how your syllabus is set up in terms of like your syllabus hierarchy. So you want to be thinking about this as your topic. The further you get down, the more you can sort of start to pick out what the questions are going to look like. So you can see here at 1.1.1, the product rule, you might have a question that focuses on the product rule, and then the cross method solution is one way that you can then think about answering that question. So that's just a good way to think about your syllabus, so you can sort of start getting yourself prepared for what you're going to be getting, like what sort of questions you're going to be getting. If your syllabus doesn't look like this, you can break it down yourself into topic, subtopic, types of questions you might see. Just a good way to think and prepare for the questions you're going to be looking at. So On to sort of some of the logistics, I guess, of your trial exams or your HSC exams in terms of their structure and the questions. So logistically, maths is or advanced maths is a 3-hour exam with 10 minutes reading time, worth 100 marks, and approximately 30% of that exam does come from Year 11 content. So if you want, check out the Year 11 lectures. I will say, and I'm going to ease some of your stress, most of that Year 11 content is stuff that you sort of do look at again in Year 12. It's things like your differentiation that you do learn in Year 12. That you do learn in Year 11. Things like, you first look at logs and exponentials in Year 11. You first look at some of that statistics stuff in Year 11. So it's stuff that you would have seen again over the Year 12 course. So don't stress too much about that fact about Year 11 stuff because it is stuff you would... Oops, sorry, I just dropped my pen. My bad. So yeah, it is stuff that you would have seen in the Year 12 course. So don't stress too much about that. I think it is important to sort of think about what you want your timing to sort of look like. Because if you know you're the kind of person who wants to have time at the end to go back over your questions, you want to think about that and factor that into your time management strategy. So you've got 3-hour exam. First, one of my biggest tips, don't do the multiple choice in the reading time. You're going to think about it too much, and if you spend a little bit too much time thinking about the multiple choice, it's when you start to second guess yourself, and then you're going to pick the wrong answer because you've just spent, way too long thinking about it. So don't do the multiple choice in the reading time. I would say allocate yourself about 15 minutes to do the multiple choice. And then I always wanted to have at least 15 minutes at the end to do a check of all my answers. So that leaves you with 2 hours and 30 minutes in the middle to do the actual questions. I think this is fairly good in terms of even if you don't finish all of the questions by this point here, I think it's always good to go back, check what you've done, and make sure all the questions that you know how to do, you're going to get the marks for them because you haven't made little errors here and there. So I would say that's fairly common sort of timing. You will find probably that it doesn't take you the total 15 minutes to do the multiple choice. It might not take you the total 2.5 hours to do the questions. So if you work through it quicker, you just have more time to sort of check your stuff at the end. So in terms of the questions themselves, questions 1 to 10 are multiple choice questions, 1 mark each, 10 marks in total. Always remember that multiple choice questions are only worth 1 mark. They are not worth agonizing over if you're a little bit confused about one of the solutions. If it takes you more than 15 minutes to do the multiple choice, I would say guess an answer and come back to it if you have time, because they're only worth 1 mark. They're just not worth agonizing over. Then your short answer questions are worth 90 marks in total. You will find most of them have sort of multiple parts. So it'll be like, question 11A, 11B, 11C. And typically those parts A, B, and C all have something to do with each other. It might not be a direct follow on, but A, B, and C might all be different types of integration or different differentiations, or, they're all questions about arithmetic sequences or something. So yeah, keep that in mind that A, B, and C usually have something to do with each other. If it is following the question stem, typically you do part A because you need to do something with it in part B. So keep that in mind if you're looking at part B and you're like, damn, I don't think I have the information to do this, because you might have found the information you need in part A. The questions typically increase in difficulty. So you'll usually have, as you probably know, your last question will be the hardest question. And when you start with the first short answer at question 11, it's going to be usually like a simple integration, differentiation, straightforward application of that. So keep that in mind, that as you move on, the paper will get harder. So just another very quick recap of the topics that we're going to be looking at today. So we've got functions, which includes graphing techniques. We've got trig functions, which has trig functions and trigonometric graphs included. We've got differential calculus, the applications of differentiation, and integral calculus. Then we're going to be looking at modeling financial situations. This is where all of your sequences and series come in. And then finally looking at statistical analysis, like I said, the forgotten one, looking at descriptive stats and bivariate data. That tends to be what people forget, and people will usually remember about random variables. But yeah, these are all of the different subtopics that we're going to be looking at in today's lecture. Okay, so we're going to start today with some trigonometry. Trig is fairly common questions you're going to get. You see your trig questions typically come up in the sense of they have a lot of applications, particularly your trigonometric graphs are typically heavy application questions, asking you to find depth of tide, times when the moon is high, things like that. So just looking at some tips for trig. So my first tip is to know all of the formulas that you might need for trigonometry. So this is knowing all the necessary formulas, which can all be found within your syllabus. You're never going to be asked something that falls outside the realm of your syllabus. So all of those formulas are available in the syllabus. You need to know what each of the variables stands for. So you need to know, for example, down here, what does sine mean? What does it mean if it's squared? What does this theta mean? So you want to know what all of your variables are. And again, just having an idea of sine, cos, and tan, and then sec, cosec, and cot. And you also want to know how to apply the formulas. Now, this seems a little bit self-explanatory, but it's remembering that you're using things like this when you get questions that are like, prove that this equals this. And you may have to use these sorts of identities and formulas to prove that, and it's not going to be so self-explanatory. It's also just recognizing all the different ways that you can sort of rewrite these identities. So, you might find that you can write 1 minus sine squared theta equals cos squared theta. So it's stuff like when you're trying to change things, you want everything to be in terms of cos, or you want everything to be in terms of sine. You can manipulate the trigonometric identities so that you can achieve that. Next, I would say super important to read the question. Again, seems obvious, but those wordy trig questions can sometimes cause you to skip over key elements of the question because there's just so much going on and there's so many words to look at. So you want to make sure that you take the time to read the questions and highlight all the necessary bits. Again, making sure you know all the variables that you're going to be asked to talk about in the question. These kinds of questions tend to be difficult to decode, so make sure you correctly and constantly are plugging in stuff in the correct formula. Okay, and then finally, there's a lot of stuff as part of the trigonometric subtopic of the syllabus, so you just want to be constantly doing practice trig questions so you get exposed to all those different question types and you're ready for anything that exam might ask you to do. So can't emphasize this enough. Practice, practice, practice. I'll highlight it too in case you missed it. Just want to do lots and lots and lots and lots of practice. Cool. So without further ado, we're going to have a look at our first trigonometry question for today. So we've got, this was part of the 2021 Sydney Grammar trial paper. I'd rate this on a scale of 1 to 3 in terms of difficulty of trigonometric questions, about a 2. So it's saying which expression is equal to the integral of 4 over 1 minus sine squared 4x dx. You've got 4 answer options, a quarter tan 4x plus c, 4 tan squared 4x plus c, tan 4x plus c, and a quarter tan squared 4x plus x plus c. So with this, I would always recommend before you read through the answer options or before you pick an answer option, try and just solve the question yourself. So, when we're looking at this particular question type, I can rewrite this thinking about this identity here, cos squared x plus sine squared x equals 1. We can rewrite that as cos squared x equals 1 minus sine squared x. So we can actually rewrite this question as the integral of 4 over cos squared 4x, okay? Remembering that we can have this be true for any number of x's that we may have possible. Just going to quickly move this up a little bit. There we go. So from here, we can then say this is going to be equal to the integral of 4 sec squared 4x dx. Thinking about changing our cos into our sec squared, okay? Then from there, we integrate, we do 4 times 1 on 4 tan 4x plus c. Then when we multiply these two things together here, we're going to end up with just 1 tan 4x plus c. So therefore, our solution to this question is going to be equal to the answer C. Okay, so we can say this one here is going to be our solution. So you will find trig questions do tend to integrate other topics as well. Didn't mean to say integrate there, but this one is integration. So you can find 10 applications of 10 within all of your other subtopics. Applications of trig within all of your other subtopics as well. Okay, so this one I would also rate a 2 in terms of difficulty. We've got the diagram above shows 3 checkpoints, A, B, and C in an orienteering event. Checkpoints A and C are such that C is 12 kilometers due north of A. One participant starts from A and walks in the direction of 50 degrees true. After 9 kilometers, the participant arrives at checkpoint B. So for part A worth 1 mark, find the distance BC and give your answer correct to 3 significant figures. And for part B worth 2 marks, what is the true bearing of C from B? Give your answer to the nearest degree. So this question, I would say they've actually been pretty nice to you in that they've already given you the diagram. So this was from the trial paper, the 2021 Sydney Grammar trial paper. So yeah, I've said they've been pretty nice in that they've given you the diagram and you don't have to draw it. If they haven't or hadn't have given you the diagram, I would still say super important to draw it so that you sort of know what you're actually looking at. And I think drawing it helps you get a really good idea of what you're actually being asked to find for parts A and B. I would say the reason that part 2 is worth 2 marks instead of just the normal 1 mark for like part A is because bearings are typically harder questions to answer. And I think a lot of people usually struggle with bearings. But we'll have a look at how you might answer this question. So we'll start by just looking at the solution for part A. So what we've been asked is to find the distance BC and give your answer correct to 3 significant figures. So the first thing I'm going to start by doing is, I'm just going to quickly redraw this diagram a little bit bigger just so you can see what I'm talking about here. Got C, B, A. This is 9 kilometers. That looks a bit like an A, but it's fine. 12 kilometers, and this is going to be 50 degrees. So we're being asked to find BC. So what we know here is that if we are being asked to find this distance here, we have been given already, I'm going to change colors quickly, 2 sides and an angle. Having 2 sides and an angle is a key giveaway that we're going to be using the cos rule. So here we've got BC is going to be equal to 12 squared plus 9 squared minus 2 by 12 by 9 cos 50 degrees here. So once we've done that, all we have to do is pop that into our calculator. So we're going to get 12 squared plus 9 squared minus 2 times A times B cos, oops, let me make sure my calculator is in degrees. may as well talk about that while I almost made the mistake. Make sure that if your question is talking about degrees, your calculator is in degrees. You don't want to accidentally do something in radians because you're going to get the wrong answer and you probably won't even recognize that your answer is wrong. So super important that, we just make sure that you recognize when you calculate it needs to be in degrees and when it needs to be in radians. So from there we get BC squared equals 86.157, so on, so on. So then we can say, therefore, BC is equal to the positive square root of 86.157. Remembering it's only going to be positive because we're looking at a distance here. So then we're going to say our BC is equal to 9.2821. And then we've been asked to round it to 3 significant figures. So we're going to get 9.28 kilometers. So with this question, important to think about, is 9.28 kilometers a reasonable distance given the information we already have? We've got one side is 12, another is 9, so we can say with pretty much almost 100% confidence that 9.28 is a reasonable distance to be having in this sort of question. So then for part B, I'm going to redraw this diagram again super quickly, just so I've got a bit of a bigger picture to show you guys what I'm doing. So we've got C, A, and B. Got 9 kilometers, 9.28 kilometers, 12 kilometers, and then 50 degrees here. So we've been asked to find what is the true bearing of C from B. Okay, so of C from B. I'm just going to quick drink of water. Sorry, had a bit of a tickle in my throat. But, okay, anyway. So what is the true bearing of C from B? So, first thing we're thinking about, if we want to find what is this angle here. So let's say call this one theta. So angle ACB is equal to theta. So in order to find that, we can use our sine rule. So we're going to have sine theta on 9 is equal to the sine of, sine of 50 degrees over 9.28, which we found. From there, sine theta is equal to 9 sine 50 degrees over 9.28. Then from there, we can find our theta, remembering again, this is in degrees. So we're going to have shift sine 9 sine 50 over 9.28. We are going to end up with 47.98. So let's round that off to 48 degrees. Now, because we have used the sine rule, we also need to check whether or not we can have an obtuse angle here. So to do that, to check obtuse angle, we do 180 minus 48, which is equal to 132. We already know that one of our angles is 50 degrees, so let's check if we could have a third angle. 132 plus 50, that is greater than 180. Therefore, theta is acute. Whenever you use the sine rule, you should always check for the ambiguous case that you may have an obtuse angle when using the sine rule. So then from there, we've found that angle, and we can say that our bearing is therefore equal to 360 minus 48, which is going to be equal to 312 degrees true. Okay, Um, if you're wondering why we can just do it like that, it's a little bit about some quick revision on angles. So if we're finding B from C, we are finding all of this. So we are essentially finding 360 degrees minus, let's just call that like little a there, minus a. Then when we've got two sets of angles that are on some parallel lines, so if I was to draw some parallel lines here, we can therefore say that our alternate angles here and here are equal to one another. So then once we found this one here, we can make this 360 minus theta to give us our bearing. Important here that they've asked you for the true bearing of C from B, so you do have to remember to do the true symbol there. So this is fairly, I would say, common style of question where they would ask you to find something in part A for trig that you then need to use in part B to find a bearing. So important to get yourself really familiar with bearings. As a general rule, usually what they've listed second is where you're going to be drawing your compass. So from whatever angle that's the angle you're going to draw your compass on to then find the bearing. So this is one of those questions that you would have looked at again in Year 12. Technically Year 11 syllabus though. So don't stress about that Year 11 stuff because you're going to do it, your Year 11 stuff, without even recognizing that it's Year 11 content. Yeah, that's about all for trigonometry in terms of the questions we're going to be looking at today. So now we are going to move on to calculus. Calculus is probably the biggest topic in terms of, I guess, like what gets made up in your exam. You do tend to do a lot of calculus in your exam, because that, I guess, covers like all your differentiation, applications of differentiation, and integration, which is a hefty part of your course. So looking at some tips for calculus, important that you don't forget your rules for calculus or the different stuff that you've got available on your formula sheet to help you do your differentiation and integration. Thinking about using the quotient rules, the product rules, chain rule, and remembering when you need to be using each of those things. If it helps you to use flashcards to remember when you need to be doing each of those things, go ahead, make some flashcards. Super important to remember when to use them in particular. I think most people remember the rules themselves because they are in your formula sheet, so you don't need to think too hard about remembering them. But yeah, just remembering when to use them is super important. Next, I'd say reading the question is really important. This seems so self-explanatory, like of course you're going to read the question before you answer it, but particularly like actually making an effort to read and understand the question, especially for your really hard application style questions. I think the best way to do this is to draw diagrams and annotate them. This is particularly important with the diagrams for doing optimization questions, so you know what you're actually trying to find. And then again, just like with trig, practice until your eyes fall out. It's so easy to forget how to use rules in calculus and to sort of get out of habit with when particular things need to happen. So things like remembering that the derivative of sine x is cos x, but then, the derivative of cos x is negative sine x, things like that. So you want to make sure that you're constantly practicing your skills and constantly exposing yourself to different question types. So yeah, super important to just keep practicing. So the first question we're going to look at for calculus today, it's going to be hard because it's worth 5 marks for one question. So I have rated this a 3 in terms of difficulty. So this is from the 2022 King's School trial paper, looking at the syllabus area of calculating area under curves. So the figure below shows region R bounded by a curve, a tangent to the curve at B, and the x-axis. So it's giving you here the equation for this line is y equals 2x minus 1 all to the power of 4. And then you've got this point B here is 1, 1. Okay, really important that you actually read the diagrams. You can see that they haven't given you this information here or here in the question itself. So you need to actually read the diagram to know that. Then it's asking you to calculate the area of the region R. Okay, calculating area under and between curves is probably one of the hardest parts of calculus in Year 12. So if you think that this question is going to be a bit tricky, no stress, it is going to be hard. So yeah, I'll give you just 2 seconds to quickly think about that. I'm just going to check my iPad's got enough charge. Okay, we're good. So yeah, I'll just give you a few seconds to quickly think about this question and think about how might you approach this. And I also want you to think about why would this be worth 5 marks for what is seemingly just some integration. Okay, so we've got all sorts of things that we are going to need to work out here. So looking at this question, first thing we're going to be needing to look at is we've got our equation is equal to, for that line, y equals 2x minus 1 all to the power of 4. Okay, so we're going to have a y dash equal to 8 2x minus 1 to the 3. So here we've just done 4 times the differential of inside the brackets to get this 8 here. Then 2x minus 1, and then you've got your n minus 1 there for that 3. So then we want to be thinking about here, what is going to be the gradient of our line at the point 1, 1, which is where we've got here, where we've got this little bit here. So at 1 minus 1, oh, not 1 minus 1, 1, 1, we've got gradient equal to 8 times 2 times 1 minus 1 to the 3. So our gradient here is going to be equal to 8. So our tangent B is going to be equal to y minus y1 equals mx minus x1. Okay, from there, simplify that, and we'll get the equation of our line is going to be 8x minus 7. Okay, so then from there, what we then need to do is we want to sort of try and find sort of like an area of a triangle to sort of help us work out what is going to be the area of our R down here. So in order to find that, what we want to find is an x value for when we are going to be intercepting the x-axis. So then from there, we want to make 8x minus 7 equal to 0 so that we can find that x-intercept for our line here. Then we're going to have 8x equals to 7, and then x is equal to 7 on 8. Okay, so what we're finding here is, I'm going to erase some of this so I can make it a little bit clearer, is here we are finding the area of this triangle here that our straight line is making. So then what we do, we're going to have to find what is going to be the area of our triangle. Okay, so to find the area of the triangle, what we want to do is do half the base times the height. So in order to do that, we're going to have to do half. Our base is going to be our 7 on 8. So we're going to end up with 1 on 8 times 1 times the half to find the area of our triangle there. From there, we're going to end up with 1 on 16 as the area of the triangle. I probably should have written that down. As the area of our triangle. So from there, we need to find what is actually going to be that area R. Okay, so how can we find that area R? We're going to do the integral from 1 to a half of 2x minus 1 to the 4 dx minus the area of the triangle that we found. Okay, because what we're doing is finding the area from this point down here for our curve, and then we just need to subtract the area of our triangle off in order to find just the area of the curve itself. So then from there, we're going to get area equal to 2x minus 1 plus n plus 1 up there, all by 2 times the 5 is 10, between 1 and a half minus 16. So then we're going to get 1 over 1/10 minus 0 minus, oops, I should have written 1 on 16. So we can go 1 on 16, pop that in our calculator. And we're going to get 3 on 80 units squared. So for this question, hopefully you can see why it was worth 5 marks. You had to do quite a fair bit to get the solution to this question. You had to work out the equation of a line. You had to find you had to recognize that you needed to find the triangle. Then you had to find the integral and then subtract the triangle from that integral. So yeah, it's a fairly hard question. So yeah, don't be too discouraged if you would have found this initially hard. Hopefully you can see where everything comes from now. So yeah, hopefully you see, I think probably the hardest part is this triangle. So I'll look at that a little bit more. So hopefully you recognize the reason that this little base is equal to 1 on 8 is because if we know up to the intercept, it's 7 on 8, and we know at the point 1 where we're coming down, it's equal to 1, then we do 1 minus the 7 on 8 to get us that 1 on 8 as the base. Then we know the height is just going to be the coordinate, the y coordinate of our point B, and we do half times base times height, which is where that half comes from as well. Okay. So yeah, that's that question. Fairly hard, but hopefully you know how to answer that now. So another fairly hard question from the 2021 Hurlstone trial paper. So this was a 2-part question, also totaling 5 marks, although that 5 marks is spread across 2 questions. So a piece of string of length 6 meters is cut into 2 pieces. One piece forms a square with sides x, and the other piece forms a circle. For 1 mark, show that the radius of the circle in terms of x is given by r equals 3 minus 2x on pi. And then hence find the lengths of the 2 pieces of string which obtain the minimum area, leaving your answer in terms of pi. Really common for optimization questions to be worth a fair few marks, so this is pretty stock standard. Your optimization questions also tend to be quite difficult, which is why this is sort of a 3 in terms of difficulty. And I was going to say something else, but now I can't remember. Oh, it's also super common for your optimization questions to give you sort of something in part 1, so that even if you can't find it in part 1, you can use it in part 2. So don't be discouraged if you can't find or can't prove or show whatever it is in part 1, because they usually give it to you so that you can then use it in part 2, even if you can't find it in part 1. So looking at the first part of that question. So we want to be thinking about how we can show that the radius of the circle in terms of the x is given by r equals 3 minus 2x on pi. So for this, you'd get 1 mark just for showing it. That's all the marks come from. So what we're doing is thinking about the total perimeter of the square and the circle is equal to 6. And we can work out that square by doing 4 times x. And then the perimeter of the circle is 2 pi r, as just the general rule for the perimeter of a circle. Then from there, we just want to rearrange, and let's say 2 pi r is equal to 6 minus 4x, just by subtracting that 4x across. Then r is equal to 6 minus 4x on 2 pi. Take 2 out of this, so you get 3 minus 2x all over 2 times the pi. Then cancel out your 2's, you're going to get 3 minus 2x on pi as your radius. And that's all you need to do for that first bit. Next, looking at the 4-mark part of finding the lengths of the 2 pieces of string that are going to obtain the minimum area, leaving your answer in terms of x. Okay, so first thing that we're going to want to do here is we're trying to find minimum area. So we want to find an equation for total area. So in this case, the area of the square is just going to be x times x, so we're going to get x squared. And then the area of a circle is pi r squared. Okay, then we sort of want to, rearrange that so that we can sort of get it in kind of terms of r. So what we do here is we can do like 3 minus the 2x squared on pi. So if we did like pi over 3 minus 2x on pi all squared plus our original x squared, so that we don't actually change the equation itself, then we'll get 3 minus 2x all squared on pi plus the x squared. Okay, so that's the first bit. Then what we want to do is differentiate our area. So sort of find an a dash. In order to find that, we'll do 1 on pi. Let me just put the brackets on that, and then 2 times 3 minus 2x times by minus 2, and then add your 2x onto that as well. Then from there, you're going to get negative 12 plus 8x plus 2 pi x all over pi. So then we want to find our second differential as well. A double dash going to be equal to 8 plus 2 pi over pi. And we know that when this is greater than 0, we're going to have a minimum point. Okay, which is what we're trying to find here in the end. It's all about finding the minimum area for our 2 objects here. So we know the minimum is going to occur when our first differential here is equal to 0. So when we get negative 12 plus 8x plus 2 pi x on pi equal to 0, essentially you can multiply that pi out. 0 times pi is 0, but you're going to get negative 12 plus 8x plus 2 pi x equals to 0. From there, we can move across our 12, so it becomes positive. 2 pi x equals 212. Factor out the x, that's in common with both. So we're going to have x, 8 plus 2 pi equals to 12. So that means x is going to be equal to 12 over 8 plus 2 pi when we just divide that out, which if we simplify it to get rid of that factor of 2, we're going to have 6 over 4 plus pi as our minimum value for x. So from there, we are going to have, we need to find the length required for each piece of string. So then what we're going to do is first find the length required for the square. So we know that the area, the perimeter of that square is going to be 4x. So we do 4 times 6 over 4 plus pi, which when we work that out is going to give us 24 over 4 plus pi as the length of string required for the square. Then it's a little bit harder with the circle, but because we already know what the square is, we can just do our total length of string minus what we know we're going to have for the square. There we go. And then that's just going to equal to 6 pi over 4 plus pi as the two lengths of string for our square and our circle. So, yeah, this is not too difficult in terms of actually the maths behind it. I would say the difficulty comes from knowing how to get there and knowing which little bits and bots you need to use from the question to answer this solution. So with optimization, always want to know that you're going to need to do at least the first differential, and you're also going to need to prove that it's a minimum. Now, because our a double dash doesn't have any variables in it, it's greater than 0, so automatically we can say it's a minimum, which is why we didn't need to prove that this was a minimum, because we'd already proved it with our a double dash. So yeah, that's that question. Hopefully that has made some sense. Okay. Next, looking at sequences and series. A lot of people don't like this topic, but I don't know, I quite enjoy it. Maybe not the financial maths part, but the sequences and the series I quite enjoy. But yeah, this is going to be the next topic we're looking at in our lecture. So again, like the other two, we're just going to start with some tips for sequences and series. So first tip I would have for sequences and series is to understand what the formulas mean. So like, yes, you get given the formulas, but you really want to understand what they mean, when to use them, and how you can manipulate them for the variables you're given. So you want to take some time to remind yourself which formulas to use when you're trying to find the sum of an arithmetic series, when you're trying to find a particular term in an arithmetic series or geometric series likewise. And you want to be fairly specific in terms of which geometric sequences and series formulas are you going to need to use in financial maths. If you do enough financial maths questions, you will tend to see patterns in the question types, in that most of them you will need to use the sum of geometric series formula at some point. So you want to get super familiar with understanding what that formula means and where all your different variables fit into it. Sort of going off that, you want to spend some time understanding financial maths. So your financial maths questions do seem really hard. They do tend to be worth a fair few marks, but the financial maths questions are essentially really similar, just with different numbers. So learn what you need to do for each question type, practice it, and you'll be able to answer any financial maths questions. There's only so many questions they can ask you for financial maths. So yeah, they're essentially all the same question, different numbers. So going along with that, and like every other topic, key here is practice. Just in case you thought you didn't have to practice, key tip would be practice. So make sure you do lots of practice questions. Financial maths, there is always at least one question on it to every single paper, every single year. So you should be able to find enough questions to practice. And like I said, the questions do tend to be super similar for annuities and for loans. So sort of learn to recognize patterns in questions, and you will be good to go to answer any particular questions on sequences and series and financial maths questions. Okay, so we are going to start with a question from the 2020 James Roos trial paper. So this is thinking about the syllabus point, identifying used arithmetic sequences and arithmetic series in context involving discrete linear growth. About the 2 in difficulty, it's not too difficult, you just do have to do a little bit for each question. So we've got the patterns below are made using small matchsticks. So immediately when you see that they've given you a diagram, thinking about count the matchsticks. So 1, 2, 3, 4, 5, 6. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Immediately here, whilst you might see and you might already recognize that this is arithmetic, always good to count whatever they've given you just so you can prove it. That's embarrassing. They just told you how many there was, so you didn't even need to count them. Pretend I didn't count them, but if it didn't say how many there was, do count it. Anyway, should have read that. So pattern 1 requires 6 matchsticks, pattern 2 requires 11, pattern 3 requires 16. So for part A with 1 mark, write a formula for the number of sticks xn needed to construct the pattern with number n. 1 mark for part B, what is the largest pattern number that can be constructed using 200 matchsticks? And part C, 1 mark, how many matchsticks would be needed to construct all patterns from pattern 1 to pattern 20? So with this, you'll notice that they don't actually call it an arithmetic sequence or an arithmetic series. So you are required to sort of recognize that, but hopefully if they've given you this, or you're like me, you've already counted them, you recognize you've got 6, plus 5 equals 11, plus 5 equals 16. And you're recognizing that you're adding on 5 every time. So hopefully you recognize that you've got a arithmetic series on your hand. So let's look at the solution for part A. I think some people sometimes forget that they can ask you basic questions on arithmetic sequences and series. I think sometimes people forget that they're not all going to be about financial maths. So good to sort of revise this as well. So we've got our sequence being 6, 11, 16, whatever. We've already determined that our D is equal to 5. And we can say our A is equal to 6. So, therefore, our xn that they've asked us to sort of find is going to be equal to 6 plus n minus 1 times 5. Then we're going to get 6 plus 5n minus 5. Always want to expand those brackets. And then we're going to get 1 plus 5n. And yeah, that's all you need to do for this question. It's only worth 1 mark, fairly simple question, but there we go. Part B, sorry, that's my bad. We're thinking about what is the largest pattern number that can be constructed using 200 matchsticks. So from here, we found from the previous question, 1 plus 5n is the number for xn. So for which xn are we equal to 200? So then solve minus the 1 from both sides. Pop that into your calculator. That's the case for my calculator. 199 divided by 5. And you're going to get 39.8. So with your arithmetic sequence questions, you're typically want to be rounding down because you can't make 40 complete patterns. The number of complete patterns you can do is 38. So therefore, 200 matchsticks makes 39 patterns. Okay, with your arithmetic and geometric sequences and series questions, usually you are required to sort of give it like a worded answer. So yeah, do be cautious of that, that you usually are required to do the actual worded answer. Cool. Then we're looking at part C. So we're thinking about how many matchsticks would be needed to construct all patterns from pattern 1 to pattern 20. Here, hopefully you recognize that we're trying to find the sum of the first 20 terms in our pattern. So we can use the formula Sn equals n on 2 times 2a plus n minus 1 times d. That's a new formula sheet. Don't have to remember it, just have to recognize and understand how to use it. So we're going to use it here because we're trying to find total number of matchsticks between 1 and 20. So we get S20 is going to be equal to 20 on 2 over 2 times 6 plus 20 minus 1 times, what did we say D was? 5. Then from there, our S20 is equal to, let's put that in the calculator, 2 times 6 plus 19 times 5 is equal to 1070. So therefore, you need 1070 matchsticks. Yeah, that's all you really have to do for that question. Fairly stock standard arithmetic sequence question. They've given you a pattern and you just have to apply different formulas to the question. So we're going to look next at a financial maths question, which tends to be what everybody dislikes the most. So this is a 3 in difficulty. I would say most of your financial maths questions are 3 in difficulty because they just require a lot of working out. I would typically say they're not actually that hard once you understand the logic behind each question. They just do require a lot of working. So that's why it gets a 3 on my difficulty score up here. Okay, part I. When Chris started a new job, $500 was deposited into his superannuation fund at the beginning of each month, and then the money was invested at 0.5% per month, compounded monthly. Let P be the value of the investment after 240 months when Chris retires. Show that P equals 232,175 and 55 cents, worth 2 marks. Then part II has 2 parts. You'll notice you don't get this notation anymore in your HSC exams, but this is from 2010, which is why they've got this notation for different parts of a question. So after retirement, Chris withdraws $2,000 from the account at the end of each month without making any further deposits. The account continues to earn interest at 0.5% per month. Let AN be the amount left in the account and months after Chris's retirement. For 3 marks, show AN equals P minus 400,000 times 1.005 to the N plus 400,000. And then for 2 marks, for how many months after retirement will there be money left in the account? So we'll start with part I. So what we're doing here, show P equals 232,175 and 55 cents. When we're showing the value of the investment after 240 months when Chris retires. So from here, P is going to be equal to 500 times 1.005 to the power of 240, because we've put in $500 at the beginning of each month, earning interest at 0.5% per month for 240 months. Our interest is already in the same sort of terms as our time periods, so we don't need to change that. So we've got that there. Then we've got 500 times 1.005 to the power of 239 until you get all of this in between, until we've got 500 times 1.005 to the 1, because we've only done it once at the very beginning. From here, take out the 500 as a common term. Then flip this around so that this is now down here and this is down the other end. You'll get 1.005 to the 1 plus 1.005 squared plus everything in between until you get this bit here, and you get 1.005 to the power of 240. From there, take out one set of your 1.005 and you'll get all of that multiplied by 1 plus 1.005 plus 1.005 squared plus everything in between until you get 1.005 to the power of 239, because we've taken out one of them, which is why this is now 239. From there, we can create a geometric series. So we'll get 500 times 1.005 is equal to 1.005 to the power of 240, which is our number of terms, minus 1. Then our r minus 1. Chuck that into your calculator, and hopefully it's going to give me 232,000. 1 minute. Cool. And then that spits out $232,175.55 when you round up the 5498. And that's what we would need to do to get the 2 marks for that first bit there. Okay. So then looking at part II, part 1, what we're doing here is we want to show that AN equals P minus 400,000 times 1.005 to the N plus 400,000 when he is taking out money. So when AN is the amount left in the account after N months. So our A0 is equal to P, this P here. So when we haven't taken out any money, we just have however much is put in there. Okay, our A1 is equal to P earning interest, taking out however much money we're taking out here. Okay, so he withdraws $200 from the account at the end of each month, and the account continues to earn the interest. Okay, so we're just accounting for the interest and then subtracting how much we have to take out. Then A2 is equal to A1 earned interest, oops, that should be 2,000, minus 2,000. Okay, how much is taken out. Then that's going to be equal to P 1.005 minus 2,000, all earned interest minus 2,000. So that's going to be equal to P times 1.005 squared minus 2,000, 1 plus 1.005. Okay, so in general we can say our AN is equal to A to the N minus 1 times by 1.005, so interest it's earned, minus the money we've taken out of it. Okay, so hopefully that is going to make sense. So then we can say from here, I might have to erase this so that I've got enough room. So hopefully you guys remember that. I'll rewrite that last line. This is a bit of an awkward pause. Okay, so we said that our AN was equal to A to the N minus 1 times by 1.005, so the interest minus that there. So then we could see in the pattern we just created that if we have AN, we're going to have P times 1.005 to the N, so these two N's match up, minus 2,000, 1 plus 1.005 plus everything in between until you get 1.005 to the N minus 1. Hopefully you noticed that from the pattern before as well. Here, whenever you see something like this, you're going to need to make a geometric series. So we're going to get P times 1.005 to the N minus 2,000 all multiplied by 1.005 to the N minus 1 all over 1.005 minus 1. From there we can rewrite this as P to the 1.005 to the N minus 400,000, which we get from dividing this 2,000 by that. So we can essentially sort of like cross cancelling them out. You just divide this term by this term, and that'll give you 400,000. Then you get all of that times, excuse me, sorry. All of that times by the top of the fraction that we still have. So from there, we times all of that out, we'll get p to the 1.005 to the n minus 400,000 times by the 1.005 to the n plus 400,000. If we do minus 400,000 times by minus 1 will get us plus 400,000. And then from there, what we just want to do, collect our like terms. So we're going to collect that p minus 400,000 all being multiplied by 1.005 to the n plus that 400,000 that we've got. And then just rewrite it how the question has it. So essentially these last two lines are the exact same thing, just rewriting it how the question stem has it written. And then that is how we show that our AN is equal to P minus 400,000 times 1.005 to the N plus 400,000. Worth 3 marks because you just have a lot of steps to do. So yeah, hopefully you see how that sort of question is done now. Okay, and then the final part of this financial maths question. For how many months after retirement will there be money left in the account? So essentially trying to find when does our AN equal to 0. So when do we have P minus 400,000 times 1.005 to the N plus 400,000. When does all of that equal to 0? Okay, so we can sort of rewrite that as 1.005 to the N equals 400,000 all over 400,000 minus P. Then sub that P back in. We get one, so the N equals 400,000 all over our 400,000 subtract 232,175.55. In order to get this N out of the exponential, what we then want to do, take the log of both sides, log of 1.005 to the N, which we can then just bring that N at the front because it's just an indice in a term of logs, equals log 400,000 over 400,000 minus 232,175.55. Then N is equal to, I might not rewrite this because it's just going to take a long time. So that N is equal to all of this divided by this bit here, log of 1.005, which when we pop that into our calculator, it's going to take a hot second in the calculator because there's so many numbers. Be really careful when you're putting this many numbers into your calculator that you put them in correctly, because that's another thing that you probably just wouldn't pick up on if you've accidentally miscalculated a number, because your number may still make sense. It just won't be the exact right number because, you know, you've forgotten to put in one of the zeros or something like that. So then that equals to, let me just double check I've done this right. 232.75.55 over log 1.005 equals 174.143. So if this isn't asking how many withdrawals he's making, it's asking for how many months after retirement will there be money. So then we round that up and say, therefore, 175 months there will be money. Okay, it may not be the full money that he wants to withdraw, the full 2,000, but there will still be money, which is why we round this up. Okay, so moving on to stats. Again, looking at some tips for statistics. This first bit, don't neglect easy concepts. A lot of people forget that they can still ask you about the median, they can still ask you about the interquartile range, they can still ask you about the mode, they can ask you about pretty much whatever they please in your HSC questions, okay? So remember that they can still ask you about that. So do some revision on the median. How do you find the interquartile range? How do you find the mode? How do you find the range? Look over them, I would say at least every 2 weeks, just so you don't forget about them. I think with statistics, trying to teach somebody else the statistics stuff will help you understand the topic more. Whether that's actually trying to teach someone in your, like one of your friends, one of your families, or just like imagining yourself like running a lecture like this, trying to teach a group of year 12 students about a particular concept will help you just understand things a little bit better, I think. So I would definitely recommend that. And in case you couldn't have guessed it, practice. There aren't a lot of questions on stats because it's fairly new to the HSC. So you'll only be able to use the past few years' papers. So use your trial papers as a starting point. Ask around for more questions. Look at your textbooks. Get your hands on a few textbooks if you can. And just have a look at all the different sorts of stats questions that you might get asked about. Okay, I'm just going to quick drink of water while you ponder. Okay, so I'm going to look at a question. This is from the 2020 James Roos paper. So consider the following graph of a normal distribution with approximately 95% of the area bound by the curve with horizontal axis and x equals 100, x equals 140 being your two limits here. Which of the following parameters best describes the curve? So immediately 95% should be triggering alarm bells, thinking of your empirical distribution, that your z-scores between -2 and 2 are going to give you 95% of the data. So this is going to be -2 and this is going to be 2, okay? So that indicates that there is going to be 40 units between these two things, okay? So what do we do from here? What is going to be our mean? What is going to be our standard deviation squared? Okay, is essentially what we're looking at here. So we're thinking our mean is essentially going to be what is exactly halfway between 100 and 140. You're going to end up with 120. Okay, then you're going to have here -1 and 1. So we can tell between the mean and our z-score of 2, we've got 20. So our z-score of 1 is going to be 130. So therefore, our standard dev is equal to 10. So our standard deviation squared is equal to 100, which gives us D as a solution for this question. Looking at another multi-choice question, consider the following graphs of two normal distributions, N1 and N2. Assuming mean 1 and standard deviation 1 are the mean and standard deviation of N1, and mean 2 and standard deviation 2 are the mean and standard deviation of N2, which of the following statements is true? So, first thing we're going to be thinking about is which one is going to have a higher mean. Your mean is essentially where is the center of your graph lying. Which graph has a higher center? That's going to be N2 because the more to the right it is, the higher that mean is. So immediately we can cross out these two because we know that the mean 2 is going to be greater than the mean. Whoops, I've done this the wrong way around. The mean 2 is going to be greater than the mean of 1. Okay? Then you want to be thinking about the standard deviation. So graphically, your standard deviation is about how spread is your graph. So how flat is the graph? The more flat it is, the higher its standard deviation is going to be. So we can see our N2 is more flat than our N1. So therefore, our standard deviation 2 is going to be greater than our standard deviation of 1. So then that leaves us with D as our answer to this question. So there's a 2 in difficulty. It does rely on you knowing what graphically the mean and the standard deviation look like, but they are not particularly hard concepts. So yeah, that's just some stuff on stats there, just some multi-choice questions. Moving on to our final topic for today, functions. Finally, the last set of tips for functions. Want to think about first about remembering what you need to put in your graphs. Always need to label the x and y axis. You need to write the equation to the graph when you're doing it after you've sketched it. You want to make sure you have an appropriate scale, because you can get marked down if you've got an abnormally small scale that makes your graph like this tiny little thing in the center of your sketch paper. And you want to make sure you label at least 2 points in the curve just to show that you actually do understand what you've drawn. So yeah, just really need to remember what to put in the graphs. Things not to forget about, things that you must revise: finding asymptotes, finding domain and range, and generally what different types of graphs look like. So you typically will do revision just innately on the straight line, your quadratic, your cubic. Sometimes you might forget about doing revision on what does a hyperbola look like, what does an absolute value graph look like, how does the equation lend itself to whatever graph you're going to sketch. And the key to doing that is to practice. So it's a fairly old topic. There's heaps of questions from heaps of past papers. You can even look through past papers from old syllabus, and you can look through and there'll still be questions that you should be able to answer in relation to functions. A lot of functions is about graphing. Now remember, it is about graphing without using curve sketching. The question will usually specify, if it's asking you to graph, like graph y equals x squared minus 4. You're not going to get a question that easy, but just hypothetically, stay with me, without using curve sketching. So it is requiring you knowing how transformations actually look in an equation. Yeah, pretty much just relying on you knowing what transformations in equations look like. So looking at this question, so we've got the line y equals mx is a tangent to the curve y equals ln 2x minus 1 at a point P. Sketch the line and the curve on the same diagram, clearly indicating the point P. For 2 marks, so you'd get a mark for sketching the line, a mark for sketching the curve. Then for part II, show that the coordinates of P are 2m over 2m, and then 2 plus m. Sorry, I said that wrong. 2 plus m over 2m, and then 2 plus m over 2. And then hence show that 2 plus m equals ln 4 over m squared. Honestly, I probably should have given this a 3 in terms of difficulty. Probably a little bit of a hard graphing question, but we're going to do it nevertheless. So immediately what we want to be thinking about is the line y equals mx is a tangent to the curve y equals ln 2x minus 1 at a point P. So y equals mx means we are going to have a straight line. So we've got a straight line that is going to go through the origin because we don't have a plus c. So bear with me. Actually, I might draw the curve first. So we're thinking about ln 2x minus 1. Going to sort of go through, let's just say this here is going to be the point 1. Then we're going to graph our curve, let's say goes like that there. So then label it y equals ln 2x minus 1. That's going to be our point 1 there. And then we just want to draw a straight line that has a tangent to that at some point. That will do. Obviously, if you were drawing this in your exam, or if you're having a go drawing it right now, use a ruler. Then you've got P. Sorry, I don't know why I drew that so weirdly. Point P here. So yeah, thinking about the asymptote on this, going to happen at a half for the graph of y equals ln 2x minus 1. That's because we know whatever the ln is, whatever the size of bracket is, has to be greater than 0. So 2x minus 1 has to be greater than 0. So 2x has to be greater than 1. So x has to be greater than 1 on 2. So we know we're going to have an asymptote there. We can also work out sort of same thing. Our 2x minus 1 equals 1, so that we can work out our x-intercept. So then we're going to have our, which is why we get this x-intercept of 1. Yeah, pretty much that's all you need to do. Probably should label the origin as well. Yeah, cool. 2 marks there. For part B, I show that the coordinates of P are 2 plus m over 2m, 2 plus m on 2. So we're going to have, I'm just going to make this a little bit thinner, change colours so we've got a little bit of variety. So we're going to have y equals ln 2x minus 1. Then we are going to have, if we find the derivative of that, we're going to have y dash equals 2 over 2x minus 1. Sorry to think about that for a second. So then we're thinking about if our y equals mx is a tangent to the graph of y equals ln 2x minus 1, then our point P, xy, at the point xy is going to make our tangent also equal, sorry, I probably shouldn't have done equal signs there, is going to also equal 2 over 2x minus 1. Okay, hopefully that makes sense so far. So then we're going to be able to rearrange this, and we're going to be able to get 2x minus 1 equals 2 over m as our gradient there. So then 2x equals 2 over m plus 1, and we just plus the 1 across. Then we can find, if we want to divide both of those by 2, we're going to get our x point for P is going to be equal to 1 over m plus a half once we've divided both of those by 2. Then if we want to make that equal to 1 equation, we get 2 over m, 2 plus m over 2m, which is the coordinate for our x point we were trying to find. Then sub that x point into our equation for y equals mx. And we're going to get that our y point is equal to m multiplied by the x point. Then we're going to get like m, 2 plus m over 2m. Cancel those m's out. You're going to get 2 plus m on 2 as your second point there that we've been trying to find. So you get here 1 mark for getting the x point, 1 mark for getting the y point as well. Cool. So then looking at the final part of this question, show that 2 plus m equals ln 4 over m squared. So we've got our P is equal to 2 plus m over 2m on 2 plus m on 2. And our point P lies on the line y equals ln 2x minus 1. Then we're going to have our 2 plus m on 2, so our y point equal to ln of 2 times 2 plus m on 2m minus 1. Essentially thinking about the fact y equals ln 2x minus 1, just subbing in our y point and our x point into that equation. From there we can simplify into 2 plus m on 2 is going to equal ln 2 plus m on m minus 1, when we just cancel our 2's out there. All of that, we're going to get the 2 plus m on 2 equal to ln 2 on m plus m on m minus 1. So then we can essentially, you'll recognize that this would become 1, so the 1 minus 1, and we'll get 2 plus m over 2 equals ln 2 on m. So then we can multiply that 2 out. 2 plus m equals 2 ln 2 on m. Then from there we can get, what do we want to do from there? So our 2 plus m equals, we can put this 2 back up here because we just one of our log, log laws. So you're going to have ln 2 on m all squared, which is going to be 2 plus m equals ln 2 squared on m squared. So 2 plus m equals ln 4 on m squared, which is what we've been asked to show here. Okay, and then that's all you have to do for that question. I think a lot of this just relies on some good algebra knowledge as well as your function stuff. So do revise that algebra, do revise that log stuff. How can we change all this log stuff? Like, for example, if you forgot that this can become up here, you wouldn't be able to answer this question. So revise all of that log stuff as well from year 11. Okay, and I think this is our final question for today before we talk about some exam tips. What is the domain and range of the function y equals 1 over the square root of x minus 9? So we're thinking first, this has to be greater than 0, okay? Square root of x minus 9 must be greater than 0. So x minus 9 must be greater than 0. So x must be greater than 9. That's the only limit, so you can sort of write that as 9 to infinity. So immediately we can cross out these two things because the domain is not correct. Then these, you'll notice, are very, very similar, right? The only thing that's different between these two things is this is a squared bracket and this is a round bracket. So you don't even need to work out the range. It already tells you. From here, we recognized that we can't have the denominator equal to 0, right? So this is why we haven't written it as greater than or equal to. It's just greater than. So we're just going to have the round bracket because it can't be equal to 9. Okay, this hard bracket means could be like, it's like greater than or equal to. This one is just greater than. Okay, and I'm pretty sure that's our last question for today. Yeah, got some little marks there. Okay, so we're just gonna have a look, few final exam tips as my parting message to you all. Seems so self-explanatory, but make sure you understand the content. Know your weak areas, know the topics you don't like, and focus on them, okay? So don't neglect these topics just because you don't like them. You think you'll get the most payoff studying the topics that you're weak at because that's where you're going to gain the most marks, right? Because if you're, say, for example, already super confident with functions, studying more and more functions stuff isn't going to gain you any marks because you've already got those marks anyway. Where you're going to gain marks is trying to focus on the areas you're weak at that you wouldn't have got the marks for otherwise, and then work on that stuff and you'll gain the marks for that area. You want to understand what's expected from you in, sorry, that just said the HSC exam, not the trial exam. So essentially understanding the topics that you have to put in there, understanding what the questions are going to look like, understanding common question patterns for HSC style questions, and sit trial exams under exam conditions, or if you want to do HSC papers, look at the HSC papers as well. Do them under timed conditions so you can get used to the timing that you have to do for the questions. Okay, you want to be super, super familiar with how much time you're going to be able to spend on each of the areas. So don't neglect it. Whoops, sorry, didn't mean to do that. Don't neglect that stuff. It'll be fine. Just try and sit them under exam conditions. I know it's gross and I know you don't want to, and I know it's going to take up a lot of time, but it will pay off in the exam itself. So some more little stuff just about some of your goals. Do a little bit of maths every day. Even if you're not focusing on maths on a particular day in terms of like your studying, just do one question in the morning. One question from a paper every day gives you good exposure, helps you not forget the key patterns, helps you not forget the formulas you have to use. Discipline is really, really important in terms of doing well in the HSC. And it's the people who work hard and just do a tiny little bit every day will do the best. I will say schedule rest days every week. Days when you're not feeling it, days when you don't want to do as much work. Try not to feel guilty about it. I think a lot of people feel guilty taking time off during the HSC when they want to study. But even if you don't want to schedule a whole day, schedule at least a few hours every week to just rest, to do nothing, watch a movie, watch your favorite TV show, do something, do the things you love. Helps you just maintain some of your motivation so you're not so focused on studying all the time. You do want to give yourself a bit of a break. Or you'll just burn yourself out before you even sit the exams. So yeah, schedule rest days, do things that you love. And then some HSC specific study tips. Do practice exams for every topic, timed conditions. Ask your teacher if they have any topic tests available. 8-hour Notes has some topic tests. If you want to practice consolidating knowledge rather than, looking at textbook questions, our exam questions for topics that you just want to, topics you just want to get the basics down before you practice the applications, do some of your textbook exercises. Summarize your knowledge for your topics somewhere, whether that's on palm cards, making yourself summary posters, summary notes, creating a little video for yourself or like a little, podcast, like a voice memo on how to do something. Something that you can look back on in case you forget how to do something. Some stuff about reading time. I'm going to start with the don'ts. Don't do the multiple choice. You can read them in the last few minutes if you've already read through all of the other questions, but don't try to do the multiple choice in the reading time, otherwise you will just overthink it and it's going to be chaos, okay? Instead, use the reading time to look over questions, keep in mind which questions are going to take longer, and leave them, okay? Sort of make a mental note of, I think question 29 is going to be really hard. So when you get to 29, mark it, come back to it, okay? If you know it's going to take you a little bit longer and you want a little bit more time. And as you're flicking through the paper, try to recall key formulas and things such as like your plus C for integration. You never want to forget it. Recalling which differentiation or integration formula you're going to have to use. Just key formulas, key stuff for certain questions as you're flicking through that paper. A few little bits and bots about checking your working. There's a few things you want to check. Calculation errors. If you have time, go back, recalculate everything. Make sure that your inputs in your calculator are correct, because if you've done one little thing wrong, it's going to mess it up. And usually if it's just one number, you won't even notice. Check for your silly mistakes. Things like misreading something or miswriting something, positives instead of negatives. Check your units. Check that you've written plus C if you're doing integration. And just make sure you've read the question really, really well. You want to make sure you answer the question. So you can highlight parts of the question or make a plan for your response. Want to make sure your handwriting is legible so that whoever's marking can actually give you marks, because if they can't read your writing, they can't give you any marks, right? And then just read over your responses to see if you've missed any key information, any key calculations, key formulas, things like that. With your formulas, make sure you're writing out the correct formulas, especially if you're doing formulas that aren't on the reference sheet. Make sure just mentally go over in your head, okay, this is the correct formula, I've written it right. Okay, so if in doubt, write out different variations of the formula and then look at them for a bit, see which one looks more correct, which one you recognize the look of more. Alongside that, make sure you know what each variable in your formula stands for. Make sure you're plugging in the right numbers. Make sure you use the correct formulas for the correct questions. Otherwise, you've got a bit of a formula for disaster going on there. So a bit of a game plan of just a different way you can time it. So you can do sort of all the questions you can answer in under 1 minute in the first 30 minutes, then all the questions you didn't do in the next hour, and then in the next hour and a half, go through all the questions you did do, check them, and then go through the questions you've left out still and answer them as best you can. And then check through the entire paper if you have time. There's no real right way to time management in an exam. Whatever works for you, so stick to it. And yeah, I guess this is just like another way that you can think about timing in the exam. Do what works for you. So just a little bit on now to the HSC. Number one thing, go over your trial paper, analyze what you did well, and think about what didn't you do well. And not just what didn't you do well, but what are you going to do to fix that? It's all well and good to be like, oh, like I didn't do so good in trigonometry, but you want to think about what can you actually do to fix that problem before the HSC. Go over the HSC using the traffic light method. Go over the syllabus, not the HSC. Use the traffic light method. So highlight the syllabus points you feel super confident in green. Do ones you're like, yellow, and then the really hard ones red. Like I said, focus on your weak areas. Reach out for help, whether it's your teacher, your tutor, a textbook, the internet, do some research on how to answer particular questions. You want to source your practice papers and sit them under timed conditions. Mark them yourself or get them marked from your teacher so you can write out mistakes. Focus on the mistakes you make in those exams so that you can correct them before the HSC. And then always check your HSC timetable so you don't accidentally come to the wrong time, because you can't resit it. There's no resitting that HSC exam. If you miss it, you miss it. And so check the timetable, make sure that you've got the right time for your exams so you don't set yourself up for disaster there. But do your best, you'll do fine. It is what it is. You've done all of the preparation for that exam, and now all you have to do is sit it. So that's it for today's lecture. If you're watching this live and you've got any final questions, pop them in the chat to get answered. But yeah, otherwise do your best in that exam. I believe all of you can ace the exam. So good luck. And I hope you enjoyed today's lecture. So good luck for your exam, guys.